This is it. So actually, I give you the answer. So this fx is now that is easier. Over 4 x is 0 to y over 4 and minus 5 to 0. And this is a anti-symmetric odd function. So it's like you can use the Fourier odd, Fourier sine series, right? So as a Fourier sine series, I think the form is, the only thing is I think it's square root of 2 over pi. Fourier sine series. Right? Yes. Here's the Fourier sine series. Symmetry, okay. The text we can write down. Did the text write it down? I wrote it down. The text wrote down just the full Fourier series, but the Fourier sine series is just half of that, and they basically go back to just the Fourier sine part, so you're saying and then these n times and then this is the correct period because it's from 2 pi to, the period is 2 pi from minus pi to pi. So that is right. And if you are using the full Fourier series sine n, the a sub n is given by summing over, integrating that over the 2 pi period, but then you multiply by 2 and the integrate just to pi and then sine nx. Okay. Right, this is like the Fourier sine series. All right, and then you just put in the formula. I'm a plug in for fx. This is pi over 4. This is pi over 4, so it's 1/2 integrating speed. Right, and that looks trivial. And the sine this is the n minus to the derivative, that's sine and minus this. You can see there's a negative sign, so 0 will give you 1, and at pi is cosine n pi, which is minus 1, right? And then there's an n, right? So it is basically when n is even, you got 2 divided by 2 is 1 over n. Even. When n is odd, this is minus 1, so this is 0. So it means that these are b sub n, so fx go back to here. Fx is just this one. This is sum over all the even n, right? Why did I get this is odd, right? This is even. Why did I get odd even? Did I get it correctly? Nx This is psi. Oh wait, so at so minus sign, to use the minus sign to fit the limit. 0 is 1, and then minus of this one, minus this one, minus 1. Okay, so it's the other way around. So for odd n is minus 1, minus 1, minus 1 is 2. And this is odd. And even is 0. Okay. Okay, so this kind of like just save some writing with the writing and I mean, you do it line by line. I mean, less likely to make error. Okay, and so all the odd, sum of all the odd n, and the coefficient is 1 over n, so sum of all the odd n, and the coefficient is 1 over n, so it's 2n plus n. So that's the coefficient, that's the base of n, sum of only odd n, and then the corresponding sign n is 2n plus 1. Okay, so do it the other way around.
So in class, I solved this problem by finding the Fourier series of this function for the given function, and it's not what the question asks. Actually, the question asks to sum over this series to get to this function. And for completeness, I'll do this summation. Summing a series is not always possible or easy, but for this one, it turns out it can be summed. It's a little bit tricky, but we'll work that out. So basically, this series, the sine function, you can write like the imaginary part of exponential function. Like this is e to the I of this one, but you can put the ix first and then the power of 2n plus 1 outside. So then this is like a variable to this power and divided by 2n plus 1. So 2n plus 1 means that you're summing over all the odd number and the odd power of this variable. Now, the series is not immediately recognized, but in the example of the textbook, we work out a similar series. The series is like log of 1 minus z is equals to minus z, and then minus z squared over 2 divided by all the power c cubed over c and so on. Right. Then we did that by doing a simple Taylor expansion. But from this, you can also get, if you change z to minus z, this becomes log 1 plus z. Then basically, you just change the sign of all the odd power terms. So this becomes z, this becomes minus z squared over 2, this becomes plus c cubed over 3, and so on. Right. Then to get the series with all just the odd power, basically you subtract this from this. When I subtract this from there, you get rid of all the even power terms. But then you double all the odd power, so you divide it by 2. So it means that 1/2 of log 1 plus z over 1 minus z is what you want. C plus c cubed over 3, and so on. Right. So this means that this can be summed like that. And so this is the imaginary part of log Oh, and our z is e to the power of ix. So 1 minus z. Okay. And now this is taking the imaginary part of the log. So if you write this argument in polar form, then obviously only the polar angle will give you the imaginary part because the magnitude, say, if this argument is something like a e to the I b, a is a positive positive number because it's the magnitude. So magnitude is positive, and then you get only the phase angle. So you take the log of that, you get only might be you get only the phase angle here. Okay, so we only need the phase angle, and we can ignore all the positive coefficient in front because when you take the log of that, that will give you part of this term, which is the real part, which you don't need when you take the imaginary part. So we can, the first thing we can do is just get the denominator, the magnitude square, compact magnitude square, and then we can ignore that positive coefficient and write like one, and to get the absolute value, you multiply the complex conjugate or the denominator and the numerator. Okay, now you work this out. This is imaginary part of log. Multiply 1 times 1 is 1, and then this times that is -1, so cancel these two terms. And the other two terms is e to the ix minus e to the minus ix. Right. So the real part cancel, and the real part of this term also cancel. This is cosine x plus I sine x. This is cosine x minus I sine x. So cosine x cancel. So this is only imaginary part log of 2 I sine x. Right? And within this domain, x can be positive, negative. Sine x is positive when x is positive. Sine x is negative when x is negative. When you write it in polar form, this is imaginary of the log. So the magnitude obviously is just the magnitude of sine x. And then the polar form depends on the sign of x. If it is positive, then I is e to the I pi over 2. If it's negative, then it's e to the minus I pi over 2. So the sine x here. So this is the polar angle. This is this one. And so the imaginary part will pick out just the polar angle. And I forgot this 1/2 factor here. You know the 1/2. So 1/2. And so polar angle pi over 2 sine x and divided by 2 is pi over 4 sine of x. Okay, so this is what is required. Okay, so that is the how you sum the series to get the answer for this question.